All right, so here we got another application problem. And so with this one, we have the concentration of a particulate matter in parts per million T-hours after a factory ceases operation, and the day is given by this function. Find the average concentration. All right, so let's start with, well, since we have the ln, we're going to say, okay, well, let's let u equal ln of t plus 1. Du then is going to be equal to what? Well, it's going to be 1 over t plus 1. And derivative of that's just 1, and then dt. So the integral, well, I know I'm going to have integral dv is equal to integral of what's left over. And what's left over is 20 over t plus 1 squared. So I'm going to say that's 20 times t plus 1 to the negative 2, and then dt. And the only reason I'm doing that is because I know if I have it as power, it's going to be easier to integrate. So then v is equal to what? Well, it's going to be 20. Then I'm going to bring down, or that to make it add one more, it's going to be a minus 1. So it's going to be a t plus 1 to the minus 1, and then divided by negative 1. So basically negative 20 over the t plus 1. All right. So now I've got u, v, and I've got du. So now I can plug it into my thing. So I have ln of t plus 1 times, and now I have a negative 20 over t plus 1. And then I have plus the integral of, now it looks like I have, what do we have? Oh, basically it's not a plus, it's a minus, but because I have that negative there, maybe I should go in steps, not skip here. So it's a minus, then I have a minus 20, and then I'm going to go ahead and put that as t plus 1 to the negative 1. And then I'm going to multiply that by this piece, which is basically a t plus 1 to the negative 1, and then dt. So now I can show you why I said minus is a plus, so that becomes that. And then we have what? Well, we have a plus 20 times the integral of t plus 1 to the negative 2 dt. And so then this one is going to be what? Well, that's going to be plus 20t plus 1 to negative 1 over a negative 1. And so then that becomes, well, let's bring everything down here now. So minus 20 ln of t plus 1 over t plus 1. And then that becomes minus 20 over, and then we have a t plus 1. All right, so we have two fractions with the same denominator. So let's see, what can we do? We can pull out a negative 20, and then that gives us what? ln of t plus 1. And then if we pulled out a negative, that's going to become plus 1. That's all over t plus 1. So I think we've simplified that into this. And so now that goes from, what did I say? I was going from first 0 to 5. So 0 to 5. So now I plug all that in, and maybe let's plug it in, and we're going to plug it in and go up here because we probably have to do some work. So it's going to be a minus 20 ln of 5 plus 1, that's 6, and then plus 1. And so that's going to be that, and then over, and we have 6, okay? And then we'll subtract off, and then we have minus 20 ln of 1 plus 1 over 1, okay? So now let's figure out what that is. So we've got parenthesis negative 20 ln of 6, oops, plus 1 divided by 6, and then parenthesis minus, and then we have a negative 20 times ln of 1 plus 1 divided by 1, parenthesis, and then we have, let's see here, yeah, so then that gives us that. So it looks like when we do all of that, we have this one is a negative 9.30586 minus this one's a negative 20. So it's going to be 20 minus that. So that's going to be 10.694 roughly. Now they want the average concentration. So we have 0. If we divide by 0, it's 0. But if we divide by 5, that will give us the average concentration. And that divided by that is 2.1388. And our units are parts per million. So that would be our solution to that one. All right, so that's all I have for this section. So hopefully that will help you.